This is the solution for a question covering the sublearning outcome. Calculate net force on a 2D rigid body using free body diagram and equilibrium equation from Mechanic 1. We are going to find the vertical reaction at point C in this question. Our first step is to find the force equivalents for each distributed load. We are going to look at the rectangular UDL first. We take negative 4 kilonewtons per meter, negative because it is acting in a downward direction, times the length, which is 2 meters, and get the answer of negative 8 kilonewtons for the point load. Because this is a rectangular UDL, we know the centroid is in the middle. We take 2 meters divided by 2, which is equals to 1 meter. Next, we look at the triangular UDL. We take negative 2 kilonewtons per meter and multiply the length of 3 meters. Negative because it is acting in a downward direction. In mind that this is a triangular UDL, so we have to multiply 1/2, which is equals to negative 3 kilonewtons. The centroid of a right-angled triangle is distributed by thirds, as shown below. Therefore, we take 3 meters and multiply by 2/3. We get 2 meters on the left side and 1 meters on the right side. Now we have found all the point load and their locations. We can now start calculating for reaction at point C. The question has provided a coordinate system with positive pointing upward and to the right, and positive moments rotating counterclockwise. We will take the moment at point A and set up equilibrium equation, which is equals to 0. Negative 8 kilonewtons times the normal distance from point A, which is 1 meter, negative because it is rotating in a clockwise direction, plus C times 6 meters, which is rotating in a counterclockwise direction, plus negative 3 kilonewtons multiplied by 8 meters. It is negative because it is also rotating in the clockwise direction. Rearrange the equation, we will get the vertical reaction at C is equals to 5.3 kilonewtons. There will be only one reaction at C because point C is a roller support. In the diagram, we can note that point A is a pin support, which means it has both reactions acting vertically and horizontally. From the previous question, we have found the point loads and reaction at C. Now we set up an equilibrium equation for the net force of y direction, which it must equals to 0. Negative 8 kilonewtons, negative because it is acting in a downward direction. Add positive 5.3 kilonewtons, positive because it is acting upward, plus negative 3 kilonewtons, which is acting in a downward direction. Add positive AY, which the force is acting upward. Rearrange the equation, we will get AY is equals to 5.6 kilonewtons. We set up another equilibrium equation that is equals to 0 for the net force of x direction to find AX. There are no other forces in this question, they're acting in the x direction, so we get AX equals to 0 kilonewton. In this question, we have found point loads in different shapes. We identify the support at point A and C, and we set up equilibrium equations to find the reaction at point A and C, which are equals to 5.3 kilonewtons for C, 5.6 kilonewtons for AY, and 0 kilonewtons for AX.